All right, so I've put it on record. What are we doing tonight? Okay, you have some problems you can give me, I presume? Okay, hold on. All right, I gotta get it in writing mode. Okay. That it? And your job is to factor that, right? All right. I think we've talked quite a bit about factoring. What we're looking at is the product of two linear terms, a plus or minus some number and another a plus or minus some number. So the very first thing we're going to do is split up the a's like that. Now, the second thing we're going to do is what? Math is all about memorizing methodologies, okay? So when you are factoring a quadratic, don't try to do it all in one step in your head. Nobody can do that. Just follow the steps. The first step is to split up the a's. The second step is to determine both signs. That's the one everybody wants to forget. I've had 200 students in the last 5 years, and I can't get anybody to memorize that step. I don't know why. That is the second step. You can determine both signs from the information you're looking at. First of all, do they have to be the same or different? Cannot produce. Notice that when you FOIL a plus b times x plus y, the last sign is a plus by. So if you have a plus sign in front of your number, then the signs have to be the same. That's the first thing you got to realize about factoring. Okay? They don't have to be both plus, but they got to be the same, because if they were different, I would not be looking at a plus 22. Remember the steps of FOIL. When you FOIL something, the L is the last two numbers multiplied together, right? Okay, so if you get a negative sign, one of them was positive, one of them was negative. If you get a positive sign, either they were both positive or they were both negative. So at this point, we know that they are the same. Now, how can we tell what they are? Are they both negative or are they both positive? Now, look to the middle term. In other words, the constant tells you that they're both the same. The plus 22, they have to be the same. But the middle term tells you whether they're both negative or both positive. In this case, they're both negative because the middle term is negative. Okay? So that's real easy. Now, the third step is factors of 22. We're looking for two numbers to fill in here. Well, let's look at factors of 22. We have, I like writing it like this. I'm not going to change. We have 22 and 1. We have 11 and 2. And that's about it. Now, what's the rule? We're looking for the rule on factoring. We've determined how to split up the a's. That's step 1. We've determined both signs. That's step 2. Now we're looking at factors of 22 that do what? No, they add up to the coefficient on the middle term. In other words, this tells you that they add, and they're adding to 13. So what are the two factors? Yeah, and it doesn't matter. I could write 11 there and 2 there, or vice versa. It's the same thing. Now, just to show you, go ahead and FOIL those two together. What do you get? Okay, if you were to actually FOIL them, you would get this. And then the last term would be plus 22. And now those two middle terms always combine to give you this middle term, 19 minus 13a. But it's important to learn what factoring is. Factoring is the reverse of FOILing. If you don't get that, you'll never understand factoring. It's the reverse of FOILing. So the sign that's on this number is extremely important. There's only, when I multiply that number by that number, it produces that sign, which in this case is a positive. And that's the last step of FOILing. So, all right, what else we got here? Okay. Again, I'm going to put my 2 parentheses. Now, first of all, let me say one thing. These are not always factorable, but if they are, it's the easiest method to solve. So you always attempt to do it this way. If I make that 12 and 11, this is not factorable, and you got to use the quadratic formula. But if it is factorable, you want to choose that as your first technique, always. And they're trying to teach you factoring. So step 1 is what? Nope, that's step 2. What's step 1? Step 2 is figuring out the signs. What do the signs have to be? If they were both negative, would I get a negative 12 there? They have to be opposite. That's the key. They have to be opposite. And in this case, plus minus means the same as minus plus. So that's step 2 completed. Now, what's step 3? Let's go look at the factors of 12. It always has to do with the factors of this number. That's the only factors of 12. Now, what's the rule? Factors of 12 that do what? Not add. What is that sign right there? That means those factors have to subtract a 4, not add the 4. It's add if that's a plus sign, but it's always subtract if that is a minus sign. So what two factors subtract a 4? Okay? Now there's 1/4 step here, because it matters where I put the 6 and where I put the 2. I can't put a 6 on the left and a 2 on the right. That's not the same as a 2 on the left and a 6 on the right. So there's a 4th step. Whenever this is a negative sign, there's a 4th step. And the 4th step is take the larger of your two factors, put it with the sign that is in the middle term. What sign is on the middle term? So where's the 6 go? Which means the 2 goes there. Okay? Now, let's talk about checking our answers, because there's 2 ways to check your answers. One, you could multiply those 2 factors out that we just came up with and see if you get the quadratic. But in all honesty, you would be wasting a little bit of time. We know we have this term right. It's not hard to split up x squared into x times x. We know we have this term right. It's not hard to factor 12. Plus 2 times minus 6 is minus 12. So there's really only one term there that is in doubt, and it's the middle term. And the middle term comes from the inside and the outside of the FOIL. Well, if I multiply the two insides, I get plus 2x. Multiply the two outsides, I get minus 6x. Add them together, I get minus 4x. That's our middle term. That means we did it correctly. But we don't have to multiply the whole thing out. That's a waste of time. So let's do it as fast as we can. The only terms you have to check are the inside and the outside. Now, this might seem like a big deal. I'm checking my answer. But you're going to come across harder quadratics where this is a vital part of solving it. You have to do that. You have to do the inside, the outside to determine whether or not you get the middle term. It's always the middle term that's tough. The left term and the right term are never tough. It's the middle term. What else you got? Okay. All right. Notice one thing. There's no x term. That's the only thing that differentiates this from a normal-looking quadratic. A normal quadratic has an x squared term, it has an x term, and it has a number. This is different. It doesn't have the x term. Well, this actually falls in one of those special patterns. What's it called? What's this thing called? DOPS. DOPS. What does the DOPS stand for? Difference of perfect squares. Notice why this is called the difference of perfect squares. That's a perfect square, x squared. That's a perfect square, 36. And it's subtraction. So it's the difference of perfect squares. And difference of perfect squares, if I want to label it like this, always factors to the same way. A minus b times a plus b. Okay? So memorize that. That's extremely important. Okay? And learn to recognize when you are looking at difference of perfect squares. So x squared minus 36 factors to what? Okay, consider that. Okay? My a is equal to x. My b squared is 36, so b is equal to 6. So this is what I'm looking at. I'm looking at an a that is x and a b that is 6. So what is a minus b times a plus b going to be? No, it's like this. The first term is always x minus the square root of that. And the second term, you don't even have to think about it. It's always the conjugate. It's x plus 6. Okay? Now, notice what happens if I FOIL those out. I get this. X squared plus 6x minus 6x minus 36. Those always cancel. And I'm left with x squared minus 36. So whenever you see the difference of two perfect squares, it's always going to factor into square root of the first term minus the square root of the second term. I'll give you some others. Tell me what that factors into. both terms have to be perfect squares. So what does that factor into? Times. Yeah, like I said, once you get the first term, which is always minus, the second term, give no thought to it. It's just the conjugate. In other words, it's the same two things with a different sign in front. Okay? Now, there's one that a lot of people overlook. It's that one right there. What's that equal to? Is 1 a perfect square is the question. Yes, it is. So what is the answer? You got it. Now, I'm going to make it a little harder. It's not factoring. The first term here is always the square root of that. If I'm looking at difference of perfect squares, that first term has to be the square root of 4x squared. What is the square root of 4x squared? 2x. Notice that 2x times 2x is 4x squared. Minus what? Huh? Second term? You got it. That's difference of perfect squares in a nutshell. Okay? All right. Tell me what else you got. All right. Now, they're making the numbers bigger, which I hate. That's no way to teach factoring, but we can deal with it. Okay. I presume they want you to do these without a calculator. Well, what kind of calculator do you have? Do you have a TX Inspire? Or do you have the TI-84? Okay, the TI-84 will not factor numbers for you. The TI Inspire will, but it's good that you're not going to do this on your calculator. First step. First step in factoring any quadratic. What's the first step? Tell me the first step. Split up the c squared. That's the first step. It's not always going to be c squared. Sometimes it'll be 2c squared. And then one of these would be 2c and the other one would be c. So what you're really doing there is splitting up the c squared. Okay? We're splitting up that entire first term. We always know that the first term of a quadratic is created by multiplying that by that only, nothing else. Okay? Now tell me what both signs are. Second step. Plus. Plus there, plus there. Okay? Now what's the third step? Give me the definition of the third step. Factors of what that do what? Perfect. In other words, it's add because that's positive. If that was a negative sign, it would be factors of 196 that subtract to 28. Now, this is a little hard to do manually, but not really. If we go through our factoring technique, what's the next set of factors? Always, whenever you're looking at an even number, just cut it in half and double the other one. That's the simplest way to go about it. So half of that is 98, half of that is 2. In other words, 2 times 98 has to be the same as 1 times 96, or 196. Okay? Now, I'm still looking at an even number. I can split it up again, which means I cut that in half. I got to double that. Well, notice that I'm looking for factors of 196 that add to 28. Well, I obviously haven't gone down far enough. There's some more factors there. I haven't found any yet that add to 28. Well, notice that that is an odd number. So I can't take half of it. It's not divisible by 3. I can't take a third of it. If I can't take half of it, I can't take a fourth of it. I can't take a fifth of it. I can't take a sixth of it. But I can take a seventh of it. And if I take a seventh of the 49, I got to multiply the 4 by 7. Now, I still don't have factors that add to 28. So what can I do here? Well, now if I look at the right-hand side, notice I can cut 28 in half, which means I would double that. Dang, I just found my answer. 14, remember the factors have to add to 28. 14, 14, I don't even have to decide which side each factor goes on. That's not because they're the same, it's because it wouldn't matter. If my two factors were 7 and 28, I could have put the 7 on the left and the 28 on the right, or vice versa, it gives you the same answer. So the only time it really matters is when this is a negative sign. When that's a negative sign, you got to be careful of which side you put each of your numbers on. But notice the process here. This is not probably the way you're taught in class on how to do this. It's just kind of the way I do it. Is I always divide the number on the left by whatever I can divide it by. And then when I get to this point, I notice that, gee, if I divide the number on the right by half and double the number on the left, I get a new set of factors. I didn't come up with these set of factors before, 14 and 14. They only became visible to me when I tried to divide the number on the right in half and double the number on the left. Okay, so this technique over here for finding factors is a really valuable one, however you do it. I know what they typically do. They typically do this. You tell me if I'm wrong. So you get these four factors. You get 7 times 7 times 2 times 2. Well, that doesn't help a whole lot with our problem. We're looking for two factors that add to 28. It's hard to come up with 14 times 14 there. I mean, not that hard, but I like my method better than the tree method, which is what they teach you. This tree method over here on the left. That's the way they teach you to factor a number. I prefer my method. It's simpler, actually. All right, what else you got? Okay. Now, this looks like a different subject, but it really isn't. This is the same exact thing we've just been doing. It's factoring that. The only difference is instead of an expression, we have an equation. We're still, the way to solve this equation is by factoring that quadratic. And I'll show you why after we do it. Factor that quadratic. What's step 1? Step 2. And step 3. Verbalize Verbalize step 3 for me. Verbalize it. We're looking for what? Factors of what? That do what? Not subtract. That's a plus sign. They got to add to 11. So what factors of 30 add to the number 11? You can do it the hard way, but you might know just thinking about it. What two numbers multiply to 30 and add to 11? Okay, if you don't know, let's do it the hard way. I want you to do it this time. What's the first step of doing it the hard way? No, there's a technique that I've used every single time. If I can cut this number in half, do it. Okay, so that makes 15. Since I cut it in half, I got to double that. 2 times 15 is the same as 1 times 30. Now, I cannot cut 15 in half. What can I do with it? Can I cut it in thirds? It's always the next thing to check. If you can't cut it in half, can you cut it in thirds? You can't cut 15 in thirds? A third of 15 is 5. So since I took a third of 15, what do I have to do with the 2? Multiply it by what? By 3. I took a third of 15. You always do the opposite. Multiply it by 3. Now I just found my factors I'm looking for. 2 factors that add to 11. And this is the stage 1 quadratics. They don't get any easier than this because I don't have to decide where my 5 and where my 6 goes. Since both signs are negative, I could have put the 6 on the left and the 5 on the right, or the way I did it. And again, if I'm checking, I don't need to check the whole thing. I just need to check that middle term. Well, the inside is minus 5x, the outside is minus 6x. Add them together, minus 11x. I'm correct. I know this term is correct, and I know that term is correct. So I don't have to do the whole FOIL. Okay? What else? Okay. This is different because it has an n squared term, it has an n term, but it doesn't have a constant. That makes it automatically easier. If there are only 2 terms in a quadratic, then it's not factoring. Well, it is factoring, but it's not difficult factoring like what we've been doing. The factoring we've been doing required a certain methodology that you had to use every time. Well, this factoring's a little different. Actually, what's the very first thing you look at when you think factoring? There's a priority of what you look at here. What's this stand for? That's always what you start with. Is there a greatest common factor here? N. What's left? If I factor out n, what do I have left? Okay, here, let me tell you how to do this. Okay. First of all, you see why I can factor out n from both terms, right? Okay, well, that means I'm dividing both terms by n. So when I factor out an n, what's left over is that minus that. Well, what's this? What's n squared divided by n? What's 6n minus 6n divided by n? Now, did we do it right? Whenever you're doing math, I want you to get in the habit of at every step of the way checking your answer. Is this times that equal to what we started with, n squared minus 6n? Yes, it is. If I distribute this n, I get n squared minus 6n. That's what I started with. Okay, now I have this. This is the fundamental first rule of algebra. I have two things multiplied together equals 0. What does that allow me to do? I got this times this are multiplied together and they're equal to 0. What has to be true? When you multiply two numbers together and you get 0, what has to be true? Can you find any two numbers that multiply together to be 0? Give me an example or two. One of them has to be 0, right? In other words, 1/4 times negative 1/4 is not 0. 1/4 times negative 4 is not 0. You only get 0 if one of the terms is 0. If I told you I have four numbers that I'm multiplying together that are equal to 0, it absolutely means one of them has to be 0. So whether it's two numbers, three numbers, or a quintillion numbers, if they all multiply to be 0, one of them is 0. And that's all it means. So what's our next step? I know that n times the quantity n minus 6 equals 0. So what has to be true? One possibility. What else? What's the other term? One of them has to be 0. Well, n has to be 0 or what? N minus 6 has to be 0. One of those two has to be 0. Well, if n minus 6 is equal to 0, then n equals 6. So I've got two possible solutions, that one or that one. Sometimes both of them are true. Usually both of them are true. Occasionally one of them is not, and it's called an extraneous solution. So you kind of have to always check your solutions. Here's our original function, or our original equation. Does 0 work? Does n equals 0 make that an equation? Okay, double check mark there, that works. How about n equals 6? Does that work? Brandon, substitute 6 for n. What do you get? What's 6 squared? 36 minus 36. So both of them work, as they usually will. So our solutions are n equals 0 and n equals 6. That's it. Okay? Just like if we didn't really do this before, but let me just bring it up just so we don't lose sight of it. If I have x minus 3 times x plus 2 equals 0, what are my solutions to this equation? it step by step. Don't try to do it all at once. Just set that term equal to 0, set that term equal to 0, and solve each equation. That's your answer. It's as simple as that. So if I said x minus 3 equal to 0, what's x? And if I said x plus 2 equals 0, what's x? That's the way you solve them always. And both of those work. In other words, if I were to plug both of those in, it does produce this equation both times. So that's the whole reason they treat you, or they try to teach you factoring, is because once you can factor a quadratic into two terms and it's equal to 0, then it's easy to solve from there, because there's only one way that one thing times another thing is equal to 0, and that's if one of them is 0. And with these quadratics, usually both of them are 0. Okay? All right, what else you got? All right. What do we want to do here first? You sure that's the problem? Okay. The way to think about this is you almost always want 0 on one side. Okay? Whether you have a standard looking quadratic or not, you want one side to be 0. And the reason is because of that first rule of algebra. If two things multiplied together equals 0, we can solve it. If we get two, if I tell you that x times y equals 2, you can't solve that. There's no solution. It's got an infinite number of solutions. But if I tell you x times y equals 0, it means either x is 0 or y is 0. Flat out. No two ways about it. So the first step here is to try to put everything on one side. What do you get? And 0 on the other. Put everything on one side, leave the coefficient of the squared term positive. It's not pretty to work with quadratics that have a negative coefficient in the squared term. So you always want this term right here to have a positive coefficient. Right now it has a coefficient of +1. Leave it over there on the left. So what do I got to do with the minus 9u? Okay, so what's my next line? Now, always leave them in order. Put that as the first term always. It's the highest power. When you're writing polynomials, put the highest polynomial exponent first, always. Equals what? That's the whole reason. That's the whole reason we're doing it, is so we can get 0 on one side. Now, the question now becomes, can you factor the left? If you can, you're going to have one thing times another thing equals 0. We'll be able to solve it. When it's in this format right here, you really can't solve it. It's got to be factored. That's why they put so much emphasis on factoring. So what's the best way to factor that? What's the very first thing you consider when you're factoring? Always. It's always what you look for first. And then you look for dopes. And then you look for the quadratic factoring that we've been mainly doing. Okay? In that order. 1, 2, 3. Always. Never this first. Always this first. Always. Because if you can factor out a greatest common factor, that may solve the problem. is there a greatest common factor here? With our equation right here, is there a greatest common factor? Don't forget the variable. Everybody forgets the variable. I don't know why everybody forgets the variable. Can I not factor out a u? Okay, so what do I get when I factor out a u? U times what? What's left over? No, let's go in order. Let's stay left to right. Let's not go right to left all of a sudden. Okay, so that's got to be a u. And remember how I get it? I'm dividing everything by that. I'm dividing everything by the thing that I factored out. Okay? Okay. Now, before we go on, we check that. Okay? We don't do the whole problem and then go back and check. That's the way, you know, there's a lot of math problems that have 12 steps in them. You can't wait till you get to the end to check. But I can check real quick. That is u squared. That is 9u. So I know I have factored it correctly. Okay? Now I got one thing times another thing equals 0. What does that mean? What are my two solutions? You got it. Now, those are the two actual solutions. Now, notice that there is a really easy mistake to make here. I made it for years. And that mistake is dividing both sides by u. Notice what happens if I take my original equation and I divide both sides by u. I'm going to divide that side by u, that side by u. What do I get? I get u equals minus 9. I only get one solution. What happened to my other solution? U equals 0. It disappeared. Why? Because when you divide by a variable that ends up being able to be 0, you lose that solution. It disappears. So you can't solve these. You want to be very careful about dividing both sides of an equation by a variable. Because if that variable can be 0, you're dividing by 0. You're violating the first commandment of mathematics. Thou shalt not divide by 0, ever, under no circumstances. So you can't always divide both sides of an equation by a variable if that variable could be 0. And we have just proved down here that it could be 0. It's either 0 or minus 9, and both work. Notice that if u is 0, 0 squared is 0, minus 9 times 0 is 0. I get 0 equals 0. So u being 0 is definitely a legitimate solution, but it disappears if you do it the faulty method by dividing both sides by that variable. So the much better way to do this problem is the way you did it, which is to add 9u to both sides, and then you end up with this. And then you get both solutions. Okay. In other words, then you do greatest common factoring, and you find the 0 solution and the minus 9 solution. That's just a little extra that it's not always obvious, but be careful about dividing stuff by a variable if it can be 0, because if that happens to be an answer, you're going to lose it. It'll disappear on you. What else? We got 10 minutes. Okay. Word problem means it's going to translate it. Go ahead. Go ahead and give it to me. I tell you what, before we even begin, give me the last sentence of the word problem. I don't even want to hear the problem. I want to hear the last sentence only. The last sentence tells us what they're asking for. Give me the true last sentence. What's the sentence before that? What are they asking for? That's always where you begin a word problem. Is what are they asking for? Are they asking you how much should you double it by? Or how much should you add to the width and the length? All right. Maybe there's a mistake. Go ahead and read the whole problem from the start. Okay. All right. That's a little bit of a different word problem. Usually you can go to the very last sentence and figure out what they're looking for. But first of all, they're talking about area. Okay? So what's the area of this? Okay. Now, read the problem again. Okay. So, I'm going to increase the width by some amount, and I'm going to increase the length by some amount. And it's going to result in an area of 480, not 240. I'm going to double the area, right? So, what's the variable they're looking for? We'll call it x. The amount to add to the width and length, correct? Okay. It's always the first step in a word problem is to define your variable. Now, what does it say? You're going to add it to the width, and you're going to add it to the length, right? And that area is going to equal double the area. So there's my new equation. Well, that's just a quadratic. In other words, all these word problems always come down to a quadratic. Well, let's solve that quadratic. Now, this is a little extra difficult because it's not equal to 0. So we actually have to FOIL those two terms, and then we have to move the 480 to the left side and set one side equal to 0. We can't set one side equal to 0 until we have FOILed those two linear terms. So go ahead and FOIL them. Nope. X times x is not 2x. Okay. Now, simplify and combine that. And write it as a regular polynomial where you always put the highest exponent first. So I know that x squared is the first term. How many x's do we have? Okay, so that's 34x, and the only number is plus 240, and that's all equal to 480, right? So now we're on this line here. What's the next step? What's one side always need to be? Quadratics. When you hear the word quadratic, think this. One side always has to be what? It's the only way you can solve it is if one side is 0. Well, how do I make one side 0? I'm looking at that right now. How do I make one side 0? How can I make the right side 0? It's currently 480. What do I have to do to make that 0? How about we subtract 480? Okay, well if I subtract 480 from the right, I got to subtract 480 from the left. Okay, now the left side becomes this, minus 240, and the right side becomes 0. Now we have it in the form of a normal looking quadratic, and we can apply our rules of factoring to solve this. And it will give us the answer for x, which is the amount we're going to add to 10 and to 24 to give us an area of 480. So, how do I factor that? In other words, it all boils down to a factoring problem, always. That's why they spend so much time teaching you factoring, is because there are so many quadratics in real life that have to be factored. First step. Second step. Could I produce a negative 240 if it was addition on both sides? My final number is going to be a positive number times a positive number. Never going to be negative. There's only one way. It has to be opposite signs. Has to be opposite because it's a minus 240. What's the third step? Verbalize it. That do what? Okay, good. Okay, let's help me with this process of factoring the number 240. What's the next row? And no, I cut the first number by half, so I got to double the other number. It's always that way. Okay, now do the same thing. You can still cut it in half. Keep going. And no, I just cut 120 in half, therefore I got to double 2. Now do it again. Do I have anything yet that subtracts to 20 to 34? No, not yet. Let's keep going. No, 15 and 16. Okay, now, can I do anything with that? It doesn't do any good to take the 16 and cut it in half. That just gives me the factors that I had above it. But what if I take the 15 and cut it in thirds? What do I get? 5, and then what do I got to do to 16? Now I cut it in thirds, so I got to triple it. In other words, what you do to the column on the right is dictated entirely by what you've done to the column on the left. If I've cut the column on the left in half, then I got to double the column on the right. If I've cut the column on the left by thirds, I got to triple the column on the right. If I've cut the column on the left by sevenths, I got to multiply the one on the right by 7. Okay? Now, I still haven't found two factors that subtract the 34, but I'm not done. I don't see any 24s on the right, so I can definitely cut that one in half and multiply this one by 2. Just found them. No, those add to 34. They don't subtract the 34, so that ain't it either. However, I'm just going to keep going. I'm going to keep going until I stop finding unique factors. Okay? Well, how about if I cut the one on the right by half? That makes it 12, and I double that. That doesn't help. It's a different set of factors, but still don't subtract to 34. If I cut the one on the right by a fourth, it turns into a 3. No, that ain't going to do it either. It always amazes me that they give you these problems that turn into 20-minute arithmetic problems, which is what that is, and we still have not found two that subtract to the number 34. We will, I promise you. One of them, it would be, I don't know. There's so many factors of the number 240 that we could probably spend 5 more minutes doing it. But I've taken you beyond your time, so I'll let you go. I won't keep force-feeding this arithmetic to you. But that's basically the way you do these problems. And this factoring process over on the far right is a really important process you need to learn. You need to learn how to factor a number because the calculator won't do it for you. It just won't. If you can't factor a number, you're going to be left in the dust. Okay? So make sure you know how to factor a number into all of its factors. Okay? All right. I will talk to you next time, Brandon.